G'day team, welcome back to another video. So today we are going to be looking at the sine rule. So we have just finished the cosine rule, now we're going to look at the sine rule. So if any triangle, big A, big B, big C, with side lengths little a, little b, little c, and opposite angles big A, big B, big C respectively, alright, so that looks like this. So triangle A, B, C, and they've got so opposing sides, little a, little c, little b, big B. We have these two results. So one we use for unknown lengths and one we use for unknown angles. Both mean the exact same thing, just makes our algebra a whole lot more simple. So for unknown lengths, we actually put the length values on top. So little a, length A, divided by the sine of big A, so the opposite angle, is equal to B, length B, divided by sine of the opposite angle B, which is also equal to C over sine big C. When we do these questions, we only ever use two of them, okay? But it just shows all three are equal. So if you're finding an unknown angle, then we want the sines to be on top. So this just makes our algebra below a lot easier, and you'll see an example of this below. So there are our two key formula. So remember, when we're looking at questions like this, we're after pairs of numbers. So we'd be able to solve a question if we had this length and that angle, and this length and the angle. So see how there's two pairs of opposite. So we've got a pair here and a pair here. See now, if I had this, I wouldn't be able to use the sine rule straight away because we don't have two pairs. We've got one pair here, but then these are missing the extra bit. But we can use strategies to find the missing number to make up the pair. All right, let's have a look at some examples. So find the unknown values in the following. So we have an unknown x and an unknown theta as well. So we need to identify two pairs of numbers with information. So straight away we've got 6 and 33. There's one pair. Now x, we don't know anything about this angle here, so we can't actually find x. But we actually have a theta. It might be unknown, but we have some information there. And we also have this 9. So they're the two pairs I'm going to use. Now because I'm finding an unknown angle, if we go back over here, we're going to use this version of the sine rule, okay? So down here, so we've got sine theta divided by 9. So sine of the angle divided by the opposite length is equal to sine of the angle divided by the opposite length. Okay, so sine theta divided by 9 equals sine 33 divided by 6. Now obviously we're trying to solve for theta, so we want to get rid of this 9. So we're going to multiply 9 on both sides. So sine theta equals 9 times sine of 33 over 6. And that means theta is inverse sine of that whole thing. So theta is equal to approximately 54.7 degrees. All right, so let's put that information in here, 54.7 degrees. All right. So cool, we found theta, now we want to find x. So for x, we actually need this angle in here. We don't know that just yet, but we do know some cool facts about triangles. So we know that the internal sum of the angles, so the sum of the internal angles must equal 180 degrees. If we know two angles, we can find the third. So we do that by doing 180, take away the other two angles. So 180, take 33, take 54.7, which equals 92.3 degrees. So that means this angle in here is 92.3 degrees. All right. So that's a key property that we will use a fair bit in this topic. So make sure you keep that in mind, that the sum of all of the internal angles of a triangle is 180 degrees. Now that we have that angle, we can find x, but because we're finding a length, I'm going to use this version of the sine rule now, okay? So we now have x divided by the opposite angle with the sine equals, and I'm going to use my whole numbers just because it makes life a lot easier, 6 divided by the opposite angle, which is 33. So 6 divided by sine of 33. We want x by itself, so we're going to multiply both sides by this sine of 92.3 degrees. So x equals 6 times sine of 92.3 degrees divided by sine of 33, which equals 11.01 centimeters. All right, just like that, that is how we use the sine rule. Hopefully this helps, and we'll see you guys in the next video. Thanks.